Welcome you all to this video lecture. Myself G. Thankam, Assistant Professor, Department of Physics from Rohini College of Engineering and Technology. I am handling the subject Physics for Information Science with the subject code PH8252. In this video lecture, I am going to discuss about the Fermi-Dirac distribution function. Course outcome of this topic is, after successful completion of this course, the students will be able to explain the Fermi function and its variation with temperature. Now we can move on to the topic, that is Fermi-Dirac distribution function. So what is the definition for Fermi-Dirac distribution function? So we have one equation, that is f of E is equal to 1 by 1 plus e power e minus ef by kt. This f of E is called Fermi-Dirac distribution function, or shortly it is Fermi function. Here E is the energy and Ef is the Fermi energy, K is Boltzmann constant and T is the temperature. This equation gives the probability for the occupation of electron in a particular energy level. So normally in a material we have large number of energy levels. In each energy level we have electrons. So these electrons have some chances for the occupation in this energy level. So that probability for the occupation of electron at a particular energy level is given by this function, Fermi-Dirac distribution function. So depends upon the value of E and Ef, we can find this f of E, and also with respect to temperature. So that is given by this Fermi-Dirac distribution function. Next I am going to explain about the effect of temperature on Fermi function. We have different cases. First case, at T is equal to 0 Kelvin, and one more condition is there, when E is less than Ef. So we have large number of energy level. E less than Ef means below the Fermi level we have energy levels. What is the Fermi function, or what is the probability below this Fermi level, that we are going to find by using the Fermi-Dirac distribution function. So on substituting these values, f of E is equal to 1 by 1 plus e power, T value is 0 and E minus Ef is negative because E is less than Ef. So negative value divided by 0 becomes minus infinity. So I have written here as 1 by 1 plus e power minus infinity. On substituting the values, you will get f of E is equal to 1. So f of E 1 means the probability is maximum. So we have 100% chance for the occupation of electron below the Fermi level. So below the Fermi level we have large number of energy level. All the energy levels are filled levels because the probability is 1, that is the probability is 100%. Then the second condition, at T is equal to 0 Kelvin, when E is greater than Ef, that means above the Fermi level, that is Ef is the reference level. Above the Fermi level also we have different energy levels, and in this level what is the probability that we are going to find? We can substitute all the values in Fermi function. So you will get f of E is equal to 1 by 1 plus e power, we have an expression E minus Ef. So E minus Ef, here we have a condition. What is the condition? E greater than Ef. So E greater than Ef means E minus Ef will be a positive value. So positive value divided by 0, that is infinity. So 1 by 1 plus e power infinity will become 1 by infinity is equal to 0. So the Fermi function 0 means the probability of occupation of electron will be 0. That means above the Fermi level no electrons will be there. So that is the second case. Then at third case is, at any temperature or 0 Kelvin, E is equal to Ef. So E is equal to Ef, when you are substituting in that expression for Fermi function expression, you will get f of E is equal to 1 by 1 plus e power E minus EF becomes 0. So 0 by any number becomes 0. So E power 0 is equal to 1. So 1 by 1 plus 1 becomes 1 by 2 is equal to 0.5. So the probability is 50%. Now we can represent this variation of Fermi function with the temperature in this diagram. So here we have at T is equal to 0 Kelvin alone. Here up to EF we have the maximum probability, that is 1, and above EF in this graph we have the 0 value. So the probability value is equal to 0. Next, at any temperature, what will happen? Here you can see the diagram. In this diagram we have Fermi function energy value at a different temperature. First at T is equal to 0 Kelvin, that is shown in this diagram. Then at T is equal to K Kelvin, T Kelvin. So at T is equal to 0 Kelvin, already we have discussed. At T Kelvin, what happened to this curve? It is not a straight line. What happened there? It automatically goes on decreasing and it reaches the value of 0. And at E is equal to EF level, the f of E value, the intersecting point is there in this graph, that is equal to 0.5, that is shown in this diagram. Okay, so this is the Fermi function and its variation with respect to temperature. Then what do you mean by Fermi energy and what is its importance? So Fermi energy, it is a maximum filled level, because above EF we have empty state. We don't have any electrons. Below EF we have electrons. So up to EF only we have filled level. So this is the maximum filled energy level at T is equal to 0 Kelvin. The importance of Fermi energy is it is acting as a reference level, because above this level we have a vacant site and below this level we have a filled state. So this reference level separates vacant site and filled state. So these are all about the Fermi function and its variation with respect to temperature. Thank you.